Chapter 1, Section 1 of the practice of statistics. Analyzing categorical data. So the objectives here are to identify categorical data with a bar graph, identify what makes some graphs of categorical data deceptive, calculate and display marginal distributions of categorical variables from a two-way table, calculate and display the conditional distribution of a categorical variable for a particular value of the other categorical variable in a two-way table, and describe the association between two categorical variables. Here's some data. We've got the frequency table, which lists over 13,000 radio stations and the type of music that they play. This is a categorical variable. I like to think about it like this. The individual here is going to be the radio station. And you say, hey, radio station, what type of music do you play? And the radio station responds with some category. Even though we've got numbers here, these just represent how many radio stations answered each of these formats. And then they took these numbers and divided them to get percentages. So those are the relative frequency. Relative to the total number of stations in the survey, 11.2% of them are adult contemporary. And we have a little round off error, so it doesn't quite add up to 100%. You can see the terms that the book uses there. Sometimes these tables are difficult to read. There's a lot of data. You know, they put these formats, looks like in alphabetical order, then put other at the bottom. But these numbers are hard to really process. These percentages are hard to process. So sometimes a graph is easier. You could do that perhaps with a bar chart or a pie graph. A bar graph like this one over here on the left, these bars can be in any order you want. So the shape of it doesn't matter so much, but we're recognizing the height. And then you've got a pie chart over here, again, in any order, and you've got these color-coded with different areas or different amounts of the stations that fall into each category. Notice that both graphs have titles. They've labeled things. They've got scales. They're easy to read. Some of them are easier to read than others. For example, from the bar graph, we can easily see that the news stations outnumber the country music stations. But over here, we might get a better idea of sort of the vast amount of stations that are in one of these three categories here that you can look through on this. Now, to keep in mind one thing, this could be hard. This particular graph's hard for me to read because I can't differentiate those colors very well to see what's what. But here, sometimes it's hard to tell percentage of the whole like you can on the pie chart. When you draw a bar graph, make the bars equally wide. Sometimes you see, especially in some newspapers or something, they've used little pictures instead of bars. Don't do it because it can be misleading. They call those pictographs. And always, of course, read the scales to see if they start at 0, to see if the graph might be leading you down a deceptive path. When a data set involves two categorical variables, we begin by examining the counts or percentages in various categories for one of the variables. So we have a two-way table. We've got the row and the columns. For example, they asked a bunch of young people what they thought their chances were of getting rich. They also asked them if they were a male or a female. So we asked all these individuals 2 questions. Both of those questions are categorical. In other words, which category would you put yourself in, male or female? Which category would you put yourself in? No chance of getting rich, some chance, probably not, 50-50, so on and so forth. And you can see these things here. It says 4,826 adults were surveyed. A little over half of them were males. And you can go through and look at these different percentages to see. A few of them think there's no chance they're going to get rich, but 5 times that many think it's an almost certainty that they'll get rich. The marginal distributions are the distributions that occur in the margins. Percentages may be more helpful than actual counts, especially if we're comparing groups of different sizes. So we can use the data in the table to calculate those marginal distributions for the rows or the columns and perhaps graph that. So for example, they took this table here and said You can look at the numbers. 194 out of the 4826, or 4% of the people, said no chance they get rich. This is not considering whether they're males or females. This is just everybody, which is why the denominator on all these 5 cases is 4826. From that, we can make a graph. It's a bar chart. We don't really care what order these are in, but sometimes it makes sense to sort of start at almost none over here and end up with almost certain over here. So it's a good logical order to put those things in. A conditional distribution of a variable describes the values of that variable among individuals that meet some specific condition. So we only consider the row or the column of interest, and we use that column or that row to make the percentages like we did before and perhaps graph them. Sometimes, if we have two different groups, we can make a side-by-side bar graph or a segmented bar graph. So in this problem, we can see we've got girls and boys separated. We might, for example, just consider the males. So I'm only considering these people here. Now, when I do a conditional distribution, I like to physically take a note card or a Post-it note or something like that and cover up all the data that's not the males. And that way I can see the only number that's going to be down here in the bottom, in the denominator, is 2459. And then these other numbers, 98, 286, and so forth, are these numbers of the males. If I wanted to, I could do the same thing for the females. And now I have two different conditional distributions, the condition of being a male, the condition of being a female. This is called the conditional distribution of their opinion among the males, or the conditional distribution of their opinion among the females. And so from that, we end up with this table. A little bit of that is obscured, but they made a segmented bar chart. And so you can see relatively or comparatively to one another how the males and the females align. Caution, even a strong association between two categorical variables could be influenced by other variables lurking in the background. So we don't know exactly why this connection may be. If we find a difference, or if we think there's a difference between males and females, it may not simply be the masculinity or the femininity, but something else perhaps is going on. So we don't know why that is yet, and we'll talk about that in a few chapters. Again, this chapter, this section involved a lot of categorical data with making bar graphs, what might make them deceptive, like a pictograph or a funky scale. Talked about using two-way tables to talk about marginal distributions or conditional distributions and how we might find an association between those two categorical variables. So that wraps up section 1 of chapter 1.